On those occasions when a radical equation has more than one radical, our primary first step should not be to isolate the radical. That's impossible. There are two of them. So the next natural thing you should say is, well, can I move all of them to the same side? If you moved all of the radical expressions to the same side, it makes squaring them to get rid of the radicals that much more difficult because you'll end up multiplying the two of them together. So the option that we're going to go with is not isolating them. It's impossible. There are two of them, and not moving them to the same side. We're just going to check to make sure that one of them is by themselves. As long as one of the radicals is by itself on a certain side, and it does not matter which radical and it does not matter which side, as long as one of them is by itself, the first step of squaring is guaranteed to get rid of at least one of the radicals. So in this example, we already have that this radical on the right is by itself. So we can just jump right to the squaring. Now you should be looking at this left-hand side, concerned that I'm now squaring a binomial of sorts, where I have a term here of 1 and a term here of root x plus 2. We'll get to that in a second. But we know that on the right-hand side, if I was to multiply root 3 minus x by itself, I would just get 3 minus x. Now on the left-hand side, if you prefer to think of foiling, you can, but really we are just doing a version of binomial multiplication, where we're multiplying that expression by itself. And you can just do each step of that multiplication. So we get root x plus 2 times root x plus 2 is just x plus 2. And then we have root x plus 2 times 1, which is root x plus 2. And then we have 1 times root x plus 2, which is the same thing again, another root x plus 2. And then we have our final multiplication, which is 1 times 1, just giving us 1. Cleaning up that left-hand side as much as we can, we have an x plus 3 from the 2 and the 1, and 2 root x plus 2's. And you can see how, because this radical started off by itself, the squaring process eliminated that radical. Did it leave us with another one? Sure. But we can just go through our normal one radical process to get rid of that leftover one. So I'm going to subtract 3 from both sides, which is going to eliminate this 3 and that 3. And then I'm going to subtract this x over to the right-hand side. We're going to try to get our radical by itself. Now, we saw in a previous example how this integer coefficient right here, this 2, could be left there as part of the squaring process. However, in this case, it actually makes sense to divide by 2 because that's going to get rid of this coefficient over here. And I'm left with root x plus 2 is equal to negative x. If I have root x plus 2 is equal to negative x, I can simply now square both sides, similar to what I did before, creating x plus 2 is equal to x squared, setting the quadratic equation equal to 0, factoring, and getting my two solutions, x is equal to 2 and x is equal to negative 1. Now, I want to go back to the original equation to check these two solutions. I don't want to check them in any of the intermediate steps. For example, I know they're going to work here, but that's no guarantee that they're going to work there. So we go back to the very beginning to our original equation to test those two answers. So our original equation was square root x plus 2 plus 1 is equal to root 3 minus x. Let's start by checking x is equal to 2. So we have 2 plus 2 plus 1, 3 minus 2. This side is equal to 4, or excuse me, this side's equal to 3. The The first radical is equal to 4, but then you have to take the square root. My apologies. This side is equal to 3. This side is equal to 1. They are not equal, so 2 is an extraneous solution. Now we check x is equal to -1, and we have -1 plus 2 plus 1 is equal to the square root of 3 minus -1. This whole radical is equal to 2. This whole radical is equal to 1. 1 and 1 makes 2, and this one checks out. So x equals -1 is our only solution for this radical equation. We had to square twice. Don't read into the squaring twice. That didn't create the extraneous solution. It could have been created earlier on when we squared the first time. But we squared once to get rid of the radical on the right. Then after we isolated that leftover radical, we squared again. We engaged our process one more time, then solving the resulting quadratic equation, then checking our solutions for anything extraneous. The process does not change if there are two radicals. You just make the decision of which one you want to isolate from the beginning. Sometimes it will be given to you, and sometimes you'll need to make that choice on your own. But either way, one of the radicals has to end up on the side by itself.